Let us continue with this example. In this part, I want us to explore data streams, buffers, file systems, and post requests in Node.js. We will have a form that a user completes, and upon completion, we will write that user input to a file. First, we will import the fs library, which is a global module included during the installation of Node.js. When we submit our form, we send a post request to our server. When we receive this post request, we want to write a message to our file. We will create an if statement where if the URL is /message and the method we send to that URL is a post request, we will write to the file a hard-coded message. We will create a response with the code 302 and redirect the user to the default URL with the /. When we run this code, we see that when we enter an input to our form, we get rerouted to our default web page. We also see that we have a message file created with our dummy text there. When handling incoming requests, it is crucial to parse and access the data they contain. Right now, a user submits a form and we want to know what they wrote in the box so that we can write it to our file. In Node.js, the data processing often revolves around handling streams and buffers efficiently. Here is how data flows in Node.js and how streams and buffers play a crucial role. Streams in Node.js are objects that let you read data from a source or write data to a destination continuously. They provide an interface for reading data piece by piece or in chunks rather than all at once, which is particularly useful when dealing with large data sets or when the data source is continuous. Buffers in Node.js are used to handle binary data. They are instances of the buffer class, which is a global object in Node.js. When data is read from a stream, it is typically read into a buffer. Buffers represent raw binary data in memory, and they are allocated outside of the JavaScript engine's heap. This allows Node.js to handle binary data efficiently. Continuing on, we have now checked that we are on the /message URL, and our server has been sent a post request. First, we will have an event listener to execute a function for every piece of incoming data. We are going to create a body variable, which will be an array to hold our request body. Now, when we receive a piece of data, we add this data to our array. Let's log our chunk of data to see what is inside of it. Now, we must register another event listener, which is the end event listener. The end event in Node.js HTTP requests is triggered once all the data has been received and the request stream has ended. It does not get triggered for each individual chunk of data. Rather, it signifies the completion of the entire data transmission from the client. Now we can process all the data that has been read in, and it is all stored in this body variable now. We will write this line parse body equals buffer.concat.toString. The line we just wrote in Node.js is a concise way to concatenate multiple buffers representing the data chunks from the HTTP request body into a single buffer, and then convert this entire buffer into a string. Basically, we recombine all the chunks of the buffer into one long message and then convert that into a string. We will console log this parsed body. When we run this, we see that the chunks we were adding to our body array were in hexadecimal format. When we parse it, we put it in a readable string format. The reason it says message equals before our input is because in our input we specify that the input made by the user will have a name message. Now we can write this text to a file by splitting the code by the equal sign and taking everything on the right side of the equal sign and write that data to a file. Now when we run this code, our message that we write in the form gets written to our file. That is data streams, buffers, file writing, and post requests in Node.js. Thank you. Here's some extra video of me just showing you how when we enter some text in the form, it is getting written to our file.